In class recently, we've just done a titration between hydrochloric acid and a standard solution of sodium carbonate. So what we had was, in our burette, we had sodium carbonate, and it was a concentration of 0.0543 moles per litre in this example. In the conical flask or Erlenmeyer flask below, we had an unknown HCl solution and methyl orange, and we said that when the methyl orange was pink in the HCl, when it turned sort of an orangey colour or even as far as yellow, that's when our titration was completed. What we found was that we ended up needing an average of 18.3 millilitres of our sodium carbonate. What I'm going to go through next with you is how we can use this information here to find the concentration of HCl. And sorry, the one thing I did forget is that we had 20.0 mils of HCl that was collected in a pipette, so that's how we knew its concentration exactly. So the next thing is, how do we calculate this? Well, being chemistry, I always like to start with a balanced equation. I'm actually only going to give the first half of it because that's what I'm going to use to do my calculations. So Na2CO3 plus 2HCl is going to go on to make water, carbon dioxide, and 2 moles in this of NaCl. But I'm not going to show the rest of that because it's not overly relevant. What I am going to do is I'm going to turn this into a bit of a table, because then I can find some things out. Where I've got the balanced equation to give me my mole ratios, and if I go down the side here, I've got amount, which makes it close to these, so one of these reacts with two of these, so therefore if I had 1 mole of sodium carbonate, there'd be 2 moles of HCl. I also am going to have my concentration here and my volume in litres. Okay, so my units are going to be moles, moles per litre, and litres for all of these. What I do know already is that my concentration of sodium carbonate is 0.0543 moles per litre, because that's what I made up for my standard solution. And I found that I needed 18.3 mils, which when converted is 0.0183 litres. I need to make sure I turn this into litres or I'm not going to get the correct result. I also know that I used 20 mils of my HCl, so that's 0.0200 litres. Again, must convert it into litres or I'm going to get the wrong answers. Right, so the reason that I put these into columns is that using the relationship of concentration equals amount over volume, so this triangle here, I can actually see which one I'm missing and work out my calculations. So I can see in this first column I'm only missing one thing, my amount. So what I'm going to do is cover N in my triangle and see that it says that it's going to be concentration times volume. So I do have those two things, concentration and volume. So if I multiply those two together, 0.0543 times 0.0183, I get 9.9369, so I'm going to say 9.94 times 10 to the negative 4 moles. Now this next step is very important. This next step is why we wrote the balanced equation. If there was 1 mole of these, there'd be 2 moles of this. So if there were 2 moles of this, I'd have 4 moles of this. The process I'm doing to go from here to here is times 2. I'm going times 2 to go from here to here. So therefore, I must do the same in my moles area here. So I'm now going to multiply 9.94 times 10 to the 4 by 2. Now with the rounding off and everything, it ends up being 1.99 times 10 to the negative 3 moles. Now here I'm just trusting my calculator. So I'm not rounding any numbers off yet, I'm just using the numbers in my calculator, but only recording them in my table to 3 significant figures. Now the question would have been asking us to find this value here, the concentration of the unknown, the hydrochloric acid. So again, I go down to my triangle and I cover what I'm trying to find. and I see that it gives me N over V. Well, I have those. There's my N and there's my V. So I put this number here, which I haven't taken out of my calculator. I divide it by 0.02 and I get 0.0994 moles per litre. And now I've actually got my answer. So I've done everything I need to. To be careful, I'm going to put that down here. The concentration of HCl equals 0.0994, and I'm going to remember my unit, moles per litre. We'll notice that it's 3 significant figures, even though it was 0.099369, I think it was. We only record it to 3 significant figures because that's how precise our equipment was.